Good morning or afternoon, wherever you all are at. Welcome. My name's Jim Mansfield. I'm a senior manager within, lead actually, our manufacturing intelligence division. I'm joined here today by John Lee and David Schultz to get into part two of what's the value when we start talking about, are you ready for digital manufacturing? So a quick agenda, we're going to go through a quick welcome, some additional introductions, talk a little bit about definitions and concepts around ISA 95 and UNS, or the Unified Namespace, and then building a UNS with what we acronym the hell here, right? Minimum Technical Requirements, the MTRs, assets, functions, and then finish up with Q&A. First, I want to give everybody on the line a little bit of information around Matrix Technologies. We are in our 42nd year today. We're a single source access to all of our clients for virtually any type of process, facility, or automation and engineering need. Today, we're roughly 326, I believe, employees, heading towards around $75 million in annual revenue. Our worldwide completed projects over 45 countries, corporate headquarters in Maumee, Ohio, and a total of 7 sites scattered across the United States. I won't bore you with the reading here. From a services standpoint, I will hit that a little bit and the capabilities below. So think industrial automation and information services. Manufacturing intelligence, which is really why we're here, and our team today that's going to talk, and process facility engineering, and then full EPC services to handle any project of virtually any size. Then our power systems analysis and design aspects, and of course all the capabilities that roll up into that. Won't go through our accolades, but obviously an award-winning organization, markets. I'll go through the read, but I think now I'm going to turn this over to John Lee and David Schultz. So guys, who are you? What do you do with Matrix? And take it away.
Yeah, so I'm David Schultz. I am a solution architect and support the manufacturing intelligence team. And what we're trying to do is help companies digitally transform, taking all that information that they have created over the last 30 some odd years, or that data they've created, and turn that into actionable information. About 25 years experience across all kinds of market sectors in process control and automation. Started off with the device layer and now sits sort of as a full stack of everything from your PLCs and your devices all the way up into your MES and connectivity with your ERP and other business systems. So it's always great to do these webinars. It's a good opportunity to talk about how we go about doing things and what makes Matrix a little bit different.
Yeah, sure. Thanks, David. And I'm John Lee. I'm a manager for Manufacturing Intelligence Solutions, so I run the implementation teams. I have a background in MES, databases, programming, been doing it about 30 years now. So as David mentioned, we are looking to help people with digital transformation, smart manufacturing, either from the ground up or in transformation, to bring more intelligence and more information. There's a lot of information that is in the facilities today that is just data and it's unused. And we help unlock that, turn it into information, and help drive decisions moving forward. So David, if you want to start us off.
Yeah, so I always like starting off, just make sure we do a quick level set. This is our part 4 of a 6-part series. And let's start with the basics of what it is that makes this a little bit different. And it's some of the definitions, it's the level set, so we all understand what everybody's talking about. So I want to talk a little bit about the ISA 95 standard. Most people are familiar with it through how they infer, how they're informed through their overall automation stack, but it is actually made up of 8 different parts within that specification. Really, there's 3 parts that I focus mostly on. That's part 1. Those are going to be your definitions of, just deciding what is. And then you're going to get into part 2, and that's your overall functionality. That's what occurs within your part two of, what are some of the boundaries? And that's really what the ISA 95 specification is trying to do, is draw boundaries on the type of data, the velocity of that data, how often it gets updated, and the format of that data. And then finally, when you get into that part four, that's where you're really more at that MES layer. That's your manufacturing execution systems, your manufacturing operations management. And that's defining things like your operations definitions, your process segments, all your requests and your response, payloads that come back from there. But the reason why I present this particular automation stack is because that's how most people within Industry 3.0 have architected their systems. ISA 95 was really meant to inform. It wasn't a thou shalt. It's this is kind of how we've been doing it, and this is what seems to work. And so what we end up with is all your devices. These are the things that are actually touching the process down here at the bottom. That moves into your control systems. That's going to be your physical PLCs, could be a DCS, or could be a SCADA system that's controlling that. All your notifications occur at this level, and that's all your HMI SCADA. So mostly this is just either controlling your particular process or it's controlling your plant. That's what exists. And of course, all that data gets historized within that data historian. Moving up that ISA architecture into that level 3, that's where all your MES, your MOM capabilities. So that's your genealogy or your track and trace. That's your OEE. That can be your work order management systems, your CMMS. So that's your computerized maintenance management system. It's really all about what are some of these other operations we use to support it. And then finally, you get into your ERP, your other business systems. So ERP, enterprise resource planning, that's somewhat your accounting function, your inventory levels, those types of things. The reason why this is important is that within Industry 3.0, the way that these systems were connected together is that all your level 0, level 1 equipment was connected into your level 2 equipment. That was connected into your level 3 equipment. That was then finally, maybe connected into your level 4 equipment. Every time you added new intelligence, you had to integrate at every layer across your stack. Some of that was just due to the underlying technology. Some of that was due to the underlying security models. So if you're familiar with the Purdue Enterprise Reference Architecture, that was largely used to build ISA 95. There's also that Purdue security model that gets utilized when we're connecting all these systems together. The point being is that it costs about $1 to go from level 0 and 1 up to 2, and then it costs about $3 to get from level 2 into level 3, and about $5 to get from to your enterprise. But now if you're adding in all this intelligence with all this smart manufacturing and smart devices, you're realizing, holy cow, if I'm ever going to get any of this data off the plant floor and turn it into automation, it's going to become very expensive, because sitting up here at the top is where that cloud environment exists, and it just starts to become very, very expensive to move all the way through. So, this is kind of how we've been doing it for the past 30 years, and well, there's a better way of doing it. So, just take a quick pause right here. Any questions, comments that people want to add in here, come back here at this point.
Yeah, so I'm monitoring the chat, David, and I do want to point out a couple things, right? So you mentioned the ISA 95 and even the Purdue reference. Those to your point are older, right? Decades old, right? And they were great standards, good practices with the technology at the time. But as that has evolved, so has the view as we look at these architectures, right? So as you mentioned, this vertical stack. Not only is it more efficient cost-wise for that total cost of ownership, there's going to be a lot more efficiency in being able to move the information around. So those are some real good points. I just wanted to reiterate some of those.
Mm-hmm. Yeah, I think just, one other takeaway is that as you look at this overall stack, most of the time, just for those efficiencies, you ended up using, one monolithic platform, which sometimes made it very difficult because, so we talk about vendor lock-in sometimes, and then that occurs. Well, now we want to create systems that are going to be a little more open, and those are some of our minimum technical requirements. So let's get into what the way that we go about doing these things now, and it's through the concept of a unified namespace. So what a unified namespace is that's your single source of truth for all your data and events that exist within your plant. And it also follows the structure of your business. So one thing that I do want to point out about the ISA 95 standard is it actually wasn't meant to give you a hierarchy and architecture. It really was just providing bounds around your functionality. And this is just a new way of looking at that exact same functionality. Your SCADA data still exists in SCADA systems. Your MES data still exists, still has all the same format, has the boundaries of where it is, the data velocity, it has all those data formats and all those functions. It's just now we're going to connect them a little bit differently through this architecture. It's a design approach of how are we going to connect all the systems together. So rather than having this point-to-point integration through what we used to do, and that how we generally perceive ISA 95, we're going to create nodes within an ecosystem so that any information that's, say, created down here at our sensors or at our SCADA level, that can easily be consumed by any of these other systems that exist at a higher level. Traditionally speaking, within your organization. So level 1, level 2 can talk directly to level 3, level 4. You don't have to pass through everything. The other thing we want to do in creating this unified namespace is that we want to add context. So sometimes we talk about, some people have said, well, I don't want to do all that integration, so I'm just going to take all my plant floor data and I'm just going to put it into the cloud. Well, the downside of that is you miss out on all of this other information and context that can be presented as you move through some of the other layers. And so, what's been sometimes described as the digital thread, although it does have a different meaning and a different context, all you're basically doing is taking these raw values and putting them in the cloud. You haven't solved the problem. You've basically moved the problem. So along with the unified namespace, we're going to create some context on what these data, how this data is going to be presented to the rest of the organization. So another piece about the unified namespace that I do want to make sure that we cover a little bit is it's just a real-time snapshot. So if you were to all of a sudden take a look at your entire enterprise and just take a peek into what data is going to be available in your unified namespace, it's just a real-time snapshot of everything that exists. So what's running on every line, how are they running? It's that process status, process health, asset health, how much energy you're consuming, what type of labor is associated with those types of things. It doesn't do any data storage. There's actually other systems that you utilize for that. So again, unified namespace, it's how all your data gets moved around and how it all communicates together. So it's the single source of truth for your data and events and the structure of your business, meaning we're going to follow that ISA 95. So that making sense, John? Any comments, questions on that?
It is, and that's a very interesting topic there is the data models, right? So in technology as a whole, even outside of manufacturing, having that contextual data or metadata, right, which is just data about data. So it's describing the data that you're consuming. That's been around a long time. So it's great to see some of these technology applications being applied within manufacturing. I think one of the other things about data models is it can be shared. You mentioned like the single source of truth. So if something that is producing it is providing all the information and context around the data it's producing, then any consumer has access to that. Mm-hmm. And I believe you'll touch on a little bit later, but another, use case in Industry 4.0 is the concept of digital twins, right? Mm-hmm. Yeah. And that's also where this data model coming down from the source and pushing up into the ecosystem, I think is going to play a larger part for enabling future technologies, right?
Yeah, absolutely. Yeah, so when you get into the digital twin, if you think about it, if you've provided your correct data models, whether as we get into the how we actually build it, it's your asset model is also going to be tied to some of your functional models. So it makes it very easy for that digital twin to be created because for all intents and purposes, you've packaged all that information in one nice unified namespace that a digital twin can then populate, and it can do all of its magic, which the digital twin does. So it gives you the ability to do some process predictive or some asset predictive or guidance on hey, run your process this way so you can get a little bit more out of it, or hey, if you keep running like this, you're going to have a problem type of thing. So
So there's inherently a lot of value built in that can be unlocked, right? Just by
Yeah.
starting with those types of building blocks.
Yeah, absolutely. So going back to that digital thread we talked about, there's a lot of these IIoT platforms that I've run across that are very good at this predictive or this asset health, or some that do some process health, but they all really make this point-to-point integration. And the challenge is, if you want to try two different platforms because you're not really sure which one's the best for your environment, what I say is build a unified namespace, use that to populate these other machine learning and AI systems. And then you can decide, okay, you know what, this company is really good at asset health, but this other company is really good at my process health of, maybe maximizing your throughput while constraining quality, those types of things. Or, yeah, it looks like you got a bearing that's going out on your compressor. You got about 3 months and you're going to have to schedule some downtime for it. So those are the types of things, rather than building two parallel systems, which oftentimes happens because now we can't expand it across. So that's what we want to do. That's where a lot of that value is.
Right. And I think you mentioned a little bit of interchangeability there with different software. I think you mentioned in the vertical stack, under the old ISA 95, you tend to get locked in with that technical debt of a single software solution, right?
Yes.
And
absolutely.
so as you look at this ecosystem, while you still have the colored blocks in there, I think you hit the nail on the head, right? So you can use best in class in different areas, and it's a much more open architecture. That's another huge value opportunity there.
Yeah, I mean, the things we're looking for is interoperability. We want to get into these data models, data governance, then of course security, and all that exists within this particular approach and strategy for how we're going to design our Industry 4.0 architecture. So a lot of our webinars up to this point, and many of the conversations I've had, are people say, okay, great. From a high level, I get it. I have these nodes in an ecosystem. It's the single source of truth. It's I'm connecting all this stuff together, but how do I, as a manufacturer, actually go out and start the process of, once I've I identified all my business processes, I know what all my technology is, and I'm going to start connecting all these systems together. I need to start building my unified namespace. And how do I do that? And that's exactly what we're going to get into here. So for starters, when you're building a UNS, we want to follow the MTRs, the minimum technical requirements that Jim talked about earlier. And this is that lightweight, report by exception, edge-driven, and an open architecture. So the open architecture really just means things play well with each other. We talked earlier about having this monolithic application. We're going to be utilizing best in class across our entire Industry 4. We want to use different systems that might provide some better functionality or that maximizes it, or maybe we want to use two similar systems, but they provide two different types of functionality. We want to make sure that we're just doing some kind of engineering effort once. So that's that open architecture, and then the data is going to be readily exchanged. And then, of course, it's lightweight. And what I mean by that is, because we're going to be producing a lot more data, we're going to be adding in sensors, and we're going to be communicating across a lot more systems. We want to make sure that whatever that data protocol that we're using to transfer that information is lightweight, because what we don't want to do is tax the existing infrastructure that is already in place. So, that's there. Sometimes we get into these network architectures that could be a problem. Well, traditionally speaking, it might be, but if you utilize a good open technology that has a lightweight communication protocol, you can move some things around. And with that, we get into that report by exception. And what this means is, instead of doing this pull response method, and of course, I always go back to the family vacation of, are we there yet? Are we there yet? Are we there yet? You don't have to ask that question. We're not there yet. It's only, when you do report by exception, it's when mom says, hey guys, we're about 5 minutes from grandma's house, start packing up your stuff, get your shoes on. That's report by exception. There's an action that needs to take place there, rather than the kids just asking, are we there yet? And then finally, edge driven. So this means all of your intelligence should be produced by the intelligence, or as close to that production of that intelligence as possible. We want our systems, I know what I know, more than anything else. I'm going to create the payload, and that data model exists out there. And that's what we mean by the edge-driven piece. So minimum technical requirements, this is what you should be looking for as you're going to build out the system and choosing the actual solutions that are there. So, and actually building a unified namespace, there's really there's sort of three different things that I focus on. The first thing is let's just start building some of these semantic data models around your assets. Most people have, assets out in utilities, whether it's a compressor or a chiller, or I typically use like air compressors or part of your air dryer system. But really, this is just going to speak to the overall what are our supporting pieces of technology. People understand what those are pretty readily, and we want to start building some of those data models because asset health is going to be part of it. Then we're going to move into actually modeling your production system itself. And we're going to still use the ISA 95 structure for that, of that enterprise site area line cell. So we're going to build out that production system based on the actual equipment that is there. And this is, part of that unified namespace, to where now we all understand when I say the concept of a line or a machine or a work center, or, whatever it's called in your particular manufacturing location, we're going to have names that are associated with that. And then finally, we're going to build out the functions that exist within that. So, not only are we going to have the model of the equipment, we're going to have the model of some of the data. This is that process health that is now going to be informing things like, what is my process? How is this line running? Do I have an active work order on it? A maintenance work order. What am I producing? What is the last thing I produced from a track and trace? This type of information will all get baked into this overall unified namespace. Then real fast before I get ahead, just from a design methodology, I utilize tags and parameters. So parameters are going to be that static information that's going to be specific to that equipment itself. And then tags are going to be the dynamic information. So, this is that traditionally when you think of what a tag is inside of a PLC, it's something that's, your AI, AO, DI, DO, that type of information. That's the tag, and that's going to get changed. So what we're trying to do and how we go about doing it, is that sort of making sense?
Yeah, that makes a lot of sense. You listed genealogy there and mentioned track and trace. That's that material management, right?
Yeah, absolutely.
Okay. Production and
Absolutely.
consumption tags, right?
Yeah.
Yep.
So let's get into it. So what I've done here is that I've now created a model of a particular compressor. I've utilized that same structure of my business. I have my enterprise, my site, my area, and we'll get into what some of these lines look like. But I've just started off out in my utilities area. I'm in my compressors, and now I have compressor one. So I've given it some parameters of just telling me where am I, and then what's my site. I also have my asset ID in here. This actually comes from my CMMS or my EAM system. So I know exactly what this asset ID is, and I can track that compressor. So if you're at a plant where you move things around, that's okay. It might exist somewhere else, but fundamentally that asset ID doesn't change. Here's the manufacturer and the model of it. I might have other things like a serial number, or you can bring in as a part of this model, you can bring in the last time somebody did maintenance on it, so you can have that kind of payload with it. So along with some of these parameters, that static data, I'm also taking a look at my flow and my temperature and my pressure. I've also built in a model of a motor. So a compressor, a data model can also have submodels in it. So now I know, who's I could have the motor manufacturer in there, and that, frame size. I can have, some of the other information that's associated with it, just like I do my compressor. But now, instead of looking at 8 different tags of information, that could exist inside maybe an OPC server, anybody can look at this and know exactly what it is that I'm looking at. It's a semantic data model that's clearly a compressor with a motor, and it exists in my utilities area within my, in this particular site. And that's what you want to start by doing, is just capturing all this information. It's now, instead of moving 8 pieces of data that don't make a lot of sense by themselves, you move it together as a semantic data model. Does this make sense?
Yeah, it does. So you're saying you kind of instantiate it based off the template, right? So you have a data model for a motor, but a motor can belong to a compressor or to other assets, right?
Yeah, absolutely.
You can move it around. Yep, absolutely.
Yeah. So now you'll be able to reutilize these things. So, and you can get even further, like say in a refinery, I could have an air compressor for my instrument air system. And I can also have a hydrogen compressor that exists out in maybe my hydrogen unit or in my reformer, somewhere where you need a hydrogen compressor. That you can now say, this isn't actually a hydrogen compressor. So if you need to start looking at some of your assets across, from site to site, even an area to area, you're making sure you're comparing like and like. Otherwise, you're just getting a bunch of compressor, values that, well, I don't know where that's coming from.
Yeah, makes sense.
Yeah, absolutely. So the next thing we want to do is that we're going to start taking a look at the actual, what's the function of our business. So as we structure it, we're now going to create what I've called a site. This is a user-defined type, and I'm going to start modeling some of the things that exist within my site. So when we get into building a unified namespace, that data goes where it sort of makes sense. And in this case, we actually, instead of at the enterprise level, all of the sites have access to a CRM. So this is your customer relationship manager, or as I like to call it, it's your customer reporting tool for management. But you can now, I'm going to do, have the object of an idea or concept of a quote. So somebody in my enterprise at Site One did a quote to Hank Hill over at Strickland Propane. So big shout out to King of the Hill. And he's looking for 200 cases of our standard orange juice. So I can get my quote number on here and an item and all that. But every time there's a new quote that's been presented by or created by somebody within the organization, that gets published out here, that any other systems that are interested in knowing, hey, when have we done quotes? Well, now you can see exactly the last quote that's there. And then, of course, if somebody is interested in that information, they can either go into the CRM or, there's other things that can be used and informed by that information being done. Same thing with an ERP. I can create a purchase order. So now all of a sudden it's, I need to get more of some juice color in here. So somebody's created over to Sentient Food Colors. Brian Adams is, we're going to send him a purchase order. We need 500 gallons of his juice color. And that's what this is defined as. So this is where you get into your SKUs and your descriptions. But as you're creating these purchase orders, again, any other system that's interested in knowing when a new purchase order is created can consume that. Or, and this is a very common one that exists, it's a manufacturing work order. I now need to make some standard blue juice for our inventory. So, what is it? What's the actual, our sales order number? What's the part number? When does it need to be made by? This is all part of the scheduling. How much do we need to make? What's our unit of measure that we're going to have for all this? And these are just examples. I would expect these to be much larger for your organization. But, the upside is that if I have a system that's monitoring quotes, you can now get into some advanced analytics that say, that's the 600th case of the standard orange juice that we've now quoted out there. I might want to start scheduling and getting that work order created because I have a pretty high confidence that we're going to be making some of our standard orange juice in the next 2 weeks. You can also tell your purchasing system, we don't have enough of the right juice color to make that order. Let's go ahead and get that material in. So this is where your machine learning, some of your AI starts to come into play. And the reason why you would want to have these systems talking to each other, because now every new quote's going to say, yep, it's time to start pulling in some things. So is that making sense, sort of how this is getting organized and the reason why we're doing it?
It sure does. And it seems critical that, as you look at the UDTs and you're building out your models, that you have to kind of do like an assessment, right? You're going to have to look at the operations, see where everything goes, right? So if a line supports like multiple work orders or has different work cells in different areas, you're going to want to be able to apply that to each one. And it sounds like the way that the models are inherited, that you can easily do that.
Yeah, absolutely. You create an instance of whatever that data model is as it's required based on how you go about and operate your particular plant. And this is one of the hard things of, is there a standard for a UNS? And the answer is no. That's like asking, is there a standard for how you operate a business? And there's some best practices, but there's really no guidebook this is exactly, if you were a juice manufacturer, this is exactly how you need to do your business. It all just depends on how you've done things. And oftentimes it's just, that's the way you've always done it. So now your systems just reinforce how you've been doing things for years.
Yep.
So now that we have the concept of a site and we have some upper level, our CRM or our ERP, we want to start getting into some of our lines. So this is going to be a line user-defined type. So now we want to create these data models of the actual process lines themselves. And so you can see in here, I have in my particular area here, and these are all very generic. This could be production or packaging. I now have my line 1. I've given it an asset ID of, and this again comes from my CMMS or my EAM, because typically your line is going to have an asset ID. And I also give it a parameter of a line number. And these are that's some of that static information that as you're rolling information up, you can actually see, okay, yeah, not only is that line number part of my namespace, but I can actually utilize this parameter for populating some information below. So that's some of the parameterization that you get into some of the underlying data that's here. But within that, I now define my cells. I have last run, which is some of my genealogy. I have a run OEE. So this tells me, my current run, what does that look like? My shift OEE. I also have some of my some of the other parameters for, what are my total counts on everything? What's my current scheduled rate and standard rate on some of this that's being informed? I have a work order. I know exactly what the state of this line is. So all this information is now packaged together in a nice snapshot of, if you were to look at what's going on line 1, you'd have a pretty good idea, and you can get into more of this information as it makes sense, which is what we're going to do. And then within that cell UDT, we're going to do the exact same thing of, now within this line 1, we're going to have cell 1. This could be in a packaging line. You have a caser, you could have a palletizer, you could have a filler. That's the same type of information. So that piece of equipment is going to have an asset ID. I'm going to tie that to a line. And this is, the reason why you want to have the asset ID in the line in here is because there can be equipment that is mobile. And so at some point you might be taking a piece of equipment that is, it's my asset ID, but I'm now on line 2. So you want to have that flexibility of being able to move this equipment around. You wouldn't necessarily call it cell 1, but within that you have a concept of your CMMS value is there. And then you also have some counters that exist within your cell itself. And this again depends on, how much information you have in your particular plant, but you're going to model it based on what your plant looks like. And then of course I also have the current state. And this is important because within a line, your line might not be down, even though one of your cells is. So there's other equipment that has some capacity for, either upstream or downstream that, ooh, I have a problem here, but that doesn't bring my line down because there's plenty of some slack in there as far as how you're going about doing it. But, these are the types of models that you want to create from, your site and your areas, or excuse me, your lines and your cells. So we've now modeled an asset. Now we're starting to model the production equipment, or what your actual manufacturing process looks like. Now we're going to move into some of that function that exists within those lines that we've talked briefly about. But before I do that, John, any questions, thoughts, comments at this point?
No, I've not seen any questions coming in, David. But this, this is really informative, right? So having these semantic models. So as you can tell, when you're looking at the different cells and you can individually see the states, as you mentioned, some of them may or may not affect the line depending on how they're laid out, whether or not there's buffer zones, and some of them just run at different speeds, right? Mm-hmm. So it could take a while to affect a line. But having that snapshot, as you described with the semantic data model, you can always look at a point in time and kind of see what everything's doing, as well as you can get other contextual information about what's going on with different areas. I think in some of the industry 3, this was very hard to pull the data together and find some common link to join data together. Oftentimes from process historians in that, you had to link it up based on time to figure out like, well, what was the work order running? And that made it very difficult. So this, being able to have that snapshot with all the contextual information seems like light years ahead, right?
Yeah, that's what we're trying to do.
Huge advantage.
As a great segue into what we're going to talk about next, the manufacturing work order. So this, data set that exists within our line UDT, this is going to be informed by the ERP. Remember, we scheduled a work order earlier. Well, now we have this work order. We're actually going to make some standard red juice, or that's what we're making on our line currently. So this is going to tell us what's our ERP, what's our manufacturing, our sales order, our manufacturing order number, what's the item, tells us what it is. It's our standard red juice. It also provides you some of the rates of, where do you want to be, that if you're now scrapping or you're scheduling or your standard rate for your performance, it tells you what all those numbers are. So it's not only your bill of materials, it's also telling you this is how you should be running this particular product on this particular line. But it's a work order payload that comes in as part of it. So now, in real time, I can take a look at what's running at this particular site in my packaging area on line 1. What am I actually making right now? And that's going to tell us, very readily exactly what that information is. And I've done the same thing for line 2 and line 3. So now let's get into the line OEE. So we talked a little bit about the performance there that's being informed by that job specification. So now we're going to take a look at that same manufacturing line. How are we doing? This is that asset health, the performance of that particular line. So I've created a run OEE. I've also created a shift OEE. So from that, I can see exactly in real time, not only what am I running on line 1 through that manufacturing work order UDT that I've created, I can also see how is that system running. So it's not just your line or your assets status, it's also your process status, it's your process health. And I can look at how is it running from a run standpoint. So, currently whatever it is that I'm running, it's my red juice that I'm doing right now. But overall on my shift, how is this overall shift looking in terms of an overall process health? Are there things that I need to be doing? And what I don't have in here is that I'll typically put in also an operator there, so I can start linking in, how do operators run various equipment, or how do different SKUs run on different pieces of equipment. So, going back to that model that I talked about earlier, if now I know I'm going to be making some orange juice somewhere in the next 2 weeks, I can also decide where I'm going to make it based on where does that process, where does that get manufactured the best. So it's the line, it's the operator, it's who's going to give me the best efficiency in my manufacturing process based on that. And all this is presented to you in real time. Since we're talking about performance, though, let's say, for instance, that there's a maintenance event. There's a downtime event. The operator is there, and traditionally this workflow is, I've got a down, cell. My caser, has got a problem, and I need to clear the jam from it. So now the operator is going to go over, try to do that. The operator can't, so the operator will then create a maintenance work order on that system. So if somebody were looking at this and saw, oh, wow, my OEE is not very good on line 1, what's going on? Well, now I can see, oh, I have a downtime event. I wonder who's doing what about it. So now I can come in and actually see, oh, there is a maintenance work order that has now been created by our CMMS system on it. So I now have a description of it. So I know what the status of it is. I have a work order number, when it's due, or when we're expected to have the operator to have this the maintenance technician there to and have what's the expectation of having this line back up and running. And so now from that full end to end of that event of line down, operator creates a maintenance work order, the technician arrives, and now I'm back in business. All of that information is now captured in context. So it's again, I know I'm working on line 1, what's there, I know my performance, I can see there's a downtime event, I can see that there is a manufacturing work order against it. So people are actually actively taking steps. I've been informed. Remember, I'm collecting all this data. I'm trying to create some actionable information, and that's exactly what this type of architecture in this system does. And I can look at that in a snapshot all in real time.
And so that information is going to be out there, right? So you mentioned the CMMS and maybe having a work order issued, right?
Uh-huh.
So if that information is being published out there, you mentioned it'd be publish and subscribe.
Yeah.
Even if I have a management system, if I later bring in some different type of notification system, the information's already being published, right? So
Absolutely.
It's already out there.
Yeah.
It's just ready to go. Anytime I see a new work order on any of the lines or any of those structures that I'm monitoring, right, subscribing to, I would just automatically see that.
Yeah, absolutely.
So that's a huge value, not have to map it vertically through every piece of software.
Absolutely.
Right?
Yeah, so that's a great piece of value, is that now it gives you that flexibility to where, sometimes the pain of change and the cost of change is greater than the pain of staying the same. Well, if you've designed your architecture, remember, we're using a common technology platform to move information across our system, across our, the design approach of a unified namespace. It means I'm unhappy with my current CMMS provider, I'm going to use something else. It now means that I just have to integrate with that technology stack that's already there. I just need to be able to have my CMMS be informed of these downtime events, or the operator creates a work order. And if I can do that, it becomes very easy to make that integration and that replacement in the future. So
Right.
The last piece is, now that operator is done. And in this particular case, I just, my last run that I did here, the operator was making some blue juice. And this tells you the begin date, tells you the end date of that, gives you a lot number of, what was just manufactured on there. So this gets published out on the last run from a genealogy standpoint. Now, I don't want to say this is going to take the place of your track and trace, your genealogy system. But what it means is other pieces of equipment can see I just finished a production run. There might be a little bit of information I want to consume from that. I know the bulk of it's going to be in my track and trace, but I can at least see that production order was done. And where this has value is that, say, somebody up in your sales enablement, or one of the people that has your that works oftentimes in a client-facing role in terms of manufacturing, that person can be informed that, oh, look, 334 is now done. I get that notification in my system. I can actually proactively call that client. Hey, wanted to let you know your order's done. It's moving to shipping, and you should have it out there shortly. So it tells you that type of information in real time, exactly what's happening. So if you think from a customer relationship management standpoint, having this type of information readily available of what's happening with my order, that's exactly how you put these systems together, because this will trigger a notification in the system. Last run is done. Pretty cool, huh, John?
Yeah, I mean, this is great. And like you mentioned, it may not replace the history or the ability to do some, I guess, intense lookups or what happened last year. But having this last run capability, that's, to me, is like when you have the PLC arrays and you're doing like dashboards or screens where you just want, maybe the last ones or what's on this last shift. Having that capability to put it right into the model and having that exposed, whether you want to do dashboard reporting or, like you said, another system wants to consume that to see what just happened. That's a pretty pivotal, right?
Yeah, absolutely.
So now I don't have to go scan another system every time just for the one previous, right? It's just there.
Yeah, absolutely. This is all part of that data model, and there's a way you can do the last 3 runs, or there's a lot of ways you can manipulate this data. Or maybe I want to have my last 3 quotes that sit in my CRM. You can have that information persist and part of that unified namespace. Generally speaking, it's only the last, because this is supposed to be the events that are there, and then if something wants to historize, that gets done in a different system. But the point here is this creates a common data model around your assets, around your overall production system, as well as your overall functions of what's happening in there. It's supposed to inform you in real time exactly what's going on. So process status, process health, asset health, and you captured all. So up to now, I've done everything in a system called Inductive Automation. It's their Ignition platform. This is just demonstrating that now I've done this exact same type of model. It's now being consumed by my engine. So it's common for the technology that we utilize in creating a unified namespace for moving information back and forth. It's going to be MQTT, or it could be utilizing the Sparkplug specification. And this is just demonstrating that everything I've moved up to now is in a Sparkplug type payload. And I can move these user-defined types, from my site systems all the way in and consume that, through a payload, so that other systems that are consuming it can look at it. But this is just demonstrating that I can have a system at site 1 with all that information and context in real time. I can do the same thing at site 2 and site 3. But you know what? We're trying to get out of this whole idea around vendor lock, right? So can other systems utilize it? And this is where we get into the minimum technical requirements of that open, lightweight, report by exception, edge driven. We're going to use a common technology to get systems and data moving back and forth. So here's that exact same payload that's now existing inside this is a company, it's called TatSoft, and this is their framework. Some people know it as Factory Studio. But here I am taking a look at that exact same payload, to where now if I have some equipment that's running in my ignition system, and then I have other sites or plants or areas that are now using a different technology, in this case it could be frameworks, to use that, I have a common technology platform that I can move information back and forth. So all that exact same information is now available in some other system that maybe you're using frameworks for all your real-time dashboarding, because the underlying technology, it does some things exceptionally well. So now you have this interoperability of all the technology that's moving back and forth. I create it in one site in one payload, but as long as that's common, I can now use it in another system. And that's tremendous value.
Yeah, so David, interesting thing. When you mentioned the enterprise there, and pulling it into different applications. I had seen before where Sparkplug B in the specification, since it includes the data model, some of those subscribers, or maybe when you push it up to the enterprise, like a site comes online, wants to start, publishing out at the enterprise level, if it subscribes to it, it can actually build out the whole data model itself, correct? Because it's all
absolutely.
included.
Yep,
All
absolutely.
the data is there.
And how that gets used, and actually both of these systems will do that, that as long as I have defined it up front, and you'll put that through on your parameters that I am a air compressor, when that data is now been about being consumed by these systems, dynamically they'll actually create that information object right in the system itself. So this now becomes into some dynamic SCADA or self-creating SCADA that immediately, if I go in and look at my utility section and I have a new compressor that comes online or a new pump or any new piece of equipment, I'm going to be able to see that in my screen without having to do anything. It's dynamically created for you. So it's that self-aware SCADA that we're going for.
Wow, self-aware.
Yeah.
That's huge. So you don't have to remap the data model at every level when you go up.
Yeah.
It's just when it subscribes, it just builds it out and it knows it's there based on all the semantic and the contextual information it's sending.
Yeah. So remember,
that is big.
The Industry 3, we now had to integrate at every layer. Now, because we've created a unified namespace, new intelligence gets produced. I have a new humidity sensor sitting somewhere. That information is readily available by the rest of the systems. Canary Labs also supports that technology so that as I'm bringing in a new line or a new site in my Canary system, it actually will dynamically start historizing all of those tags. And if I've created asset models of some of this information, so I talked earlier about my compressor, it'll actually subscribe to that utilities namespace, and it'll start creating those compressors that if I want to go in and historize those, I've created a virtual view within Canary that if there's a new compressor or when a new compressor comes online, as we integrate more and more into our unified namespace, I don't have to do anything. Operator in the morning can go in and see, oh, I have 3 compressors, go in the afternoon, and now there's 4 compressors because you had some new intelligence that's being created within your entire ecosystem. And as an operator, as a controls engineer or a systems architect, that person did not have to do anything because this technology presents that information and it gets dynamically consumed by whatever that process is.
So in Canary, you're saying it's dynamic. So if
yes.
you are historizing, say, the area for utilities and new compressors come online and they have the appropriate data models and they publish it, they're automatically historized? Canary just...
Absolutely.
Wow.
It just starts historizing it right there on the spot and in your virtual view, because I've created that, I already have defined what that asset model is. It will automatically create that that virtual view as well. That dynamically, I now was looking at 3. I did nothing. I look back at that page. I now see 4 compressors, or could be 4 of anything. Whatever that device is. You're probably not adding a lot of compressors, but maybe you're adding some new temperature monitoring capabilities around a particular area. Any of those measurements are now available, dynamically historized, dynamically viewable within your visualization. And then just, last but not least, I'll talk a little bit about HiByte. So, when it comes to, I don't necessarily need a SCADA system. I already have it. So, Ignition, Frameworks, those are 2 very good solutions for doing that. All I really want to do is start creating some data models. I don't need any of the visualization. This is where we're going to start using a company like HiByte. Some of the connectivity that HiByte does, it's SQL, it's API, it's PLC through, say, KEP server or a Kepware OPC UA. I also have a number of different connectors into some various cloud, whether it's Azure or AWS. There's an OSI Pi, their asset frames. I can start modeling all of that data, CSV files. The cool thing about HiByte is that you can have multiple data sources use multiple data sources to actually build that model, to where we were talking a little bit earlier about, well, I could create my line UDT because I'm going to go out and do a SQL query or an API call in my ERP. I'm going to go into my MES and capture some, some scheduling data. I'm going to go into my OPC server and I'm going to build up some tags. HiByte does that very well. but I can create that exact same compressor model. I can create instances of that compressor model just by utilizing this code that you're looking at right here. And when I start publishing that same data, lo and behold, this happens to be at site 3 where I published it in my utilities. Oops, I missed my compressors. But you have compressor 1, there's now my motor, and I'm seeing the exact same data that's out there. So this, again, speaks to this interoperability of I can create these data models in one platform that can be consumed by the other platforms, so that the maximum value that you want to get out of where's the best for utilizing this technology using an open technology, where does that exist within an enterprise, and I can do the same thing. So now we've looked at what, four different manufacturers that can all support this type of technology doing the exact same thing, or some of the exact same things.
That's huge. And the awareness, I think, is one of the greatest values there of just having it open. I can see it, and I know from some of our efforts, that dynamic resolution and awareness can also be filtered through not only to other applications, but even to like SCADA, right? And screens. Where you can dynamically draw things, or dashboards can dynamically also pick up and display things based on what it's seeing. So there's huge opportunity and a lot of value in having this open architecture like this.
Yep, absolutely. So, we wanted to set out to say what's some of the value of this. Well, here's the value of the interoperability, but it's more, here's the value of defining and utilizing a unified namespace for creating that single source of truth for all your data and events, following a structure of, we walked all the way from dynamically creating a manufacturing work order based on a quoting activity, having it scheduled, and even just pulled down of, all of the activity that needs to be created by that, or just being able to know right now, what's the best line that's been running, has the best performance within my entire enterprise. If I have, if I'm a large manufacturer and I have 100 different plants, just some very simple answers. I can just look it right up on my phone and know exactly, what's going well and maybe what's not going so well. All this system's now informing in real time, and I can use all types of different technology to do that. So a lot of value.
Yeah, having that capability definitely is a huge curve, like when it comes to extensibility, right? So you can almost build the extensibility right into it, into your applications, whether it's in operations management or higher levels. It can just be part of, I guess, your implementation. And so the extensibility, you don't have to go back through as another project and actually build it all in. It just starts appearing, right? That self-aware, once you start publishing it, it can be consumed invisible in other layers.
Yep.
So that is huge.
Absolutely. So now it comes to the favorite time. I don't know if there were any questions that popped in here, but now's a chance that if you had some questions about how something got done, or how you get started, let's entertain some of those right now if anything came in.
So no new ones that we have not covered.
Okay.
David, Jim, did you have any?
I really don't. I think I'm just in awe of of the different value propositions you guys have hit over the last 45, 50 minutes. When I start thinking about traditional I3O and this transition to digital transformation and digital manufacturing, it seems like the value's going up, costs are coming down. It's just an exciting time to be in this business. But
absolutely. Well, since we don't have any questions, just real fast, if you do have some more questions about this, there's contact information for John and for Jim. And of course, I'd be remiss if I didn't talk about our webinar number 5 that's coming up. So I mentioned earlier on, this was part 2 of I guess our middle sections of a 6-part series. The next one is how to stay focused. So this is more around a project management and leading some of these. Technically we can do this, but culturally, what are some of the things that we can do to help make that process a little bit smoother at our particular organization? So coming up October 17th, register now, no waiting.
Yeah, and that'll be a good session as well, right? So with digital transformation, you got to remain agile, right? And you have to be able to relook things. You have to be able to iterate, but you also have to be careful, of that technical debt and any of those holes, right? I mean, we've all heard about like pilot purgatory, right? Where you just can't move forward, right? You can't progress. And so how to stay focused, I think, is going to be an important part of the series, and hope everybody can join us in October for that.
All right, very cool. So Jim, any final words for us?
No, gentlemen, thank you. Yeoman's job today. Thank you both so much. I really appreciate the time. Thanks for all the folks that either attended or are going to be watching after the fact. And look forward to seeing you in mid-October.
All right,
All
thanks,
right.
guys.
Thank
Enjoy the rest
you.
of your day.
Thanks,
Yep, see
David.
you. Mhm.